Hi, my name is Yuan. In today's video, I'm going to show you how to calibrate a load cell using NI9237 in Signal Express. So in the video, I'm going to break it down into three parts. How to read a load cell datasheet and understand the load cell datasheet and how to apply that into your input task. Secondly, how do you calibrate your analog input module, which in this case the 9237. So it offsets the zeros and also does shunt calibration. Thirdly, I want to show you how to fine-tune your final load cell configuration so it gives you the best result. So let's get started. The first part in this exercise here, we're using this particular load cell here, KD40S, with plus and minus 10 Newton rated input. So the key load cell uses a Wheatstone bridge configurations. Therefore, the output is always going to be millivolt per volt, which the denominator is the excitation voltage. For this particular load cell, the rated input is plus and minus 10 volt. And the rated output is 0.5 millivolt per volt with up to 4 times the maximum values to the rated output. So the maximum output for this device is 2 millivolt per volt. Other key parameters to understand is the output resistance and the rated output excitation voltage. So the output resistance is what we're going to use to configure to tell our task that this is a resistance of the Wheatstone bridge, and the rated excitation voltage is the excitation voltage which we will apply to the load cell. So let's go to Signal Express. So over here, I'm going to delete the old task and then start a new one. So we go add step, we go to DEC-MX acquire because the device uses DEC-MX driver, analog input, and we go to force, bridge, and then it brings up a window which should to ask you which physical channel do you want your signal to come from. So for we use device 2, analog input 01. So which we will create, it will automatically populate your configuration window with some default settings here. On the left-hand side, the channel settings show you the physical channel. You can expand to see it, to see which device it belongs to, but it shows you the physical channel you're currently acquiring your signal from. On the right-hand side, it shows the settings, the default settings for your load cell configuration. So the first thing we want to do is that we want to apply what we read from the datasheet to the configure scale tab. So we have a minus 0.5 millivolt per volt to plus 0.5 millivolt per volt, and the rated force, input force is minus 10 Newton. So I have to change it to Newton to plus 10 Newton. Note that with the 2-point linear scale, once you have it configured, it will automatically populate, say even if the force is out of the range. So we click OK. So for now, for simplicity, we will use Newton, and then our minimum and maximum is up to 4 times the rated input. So that will be 10 newtons times 4, so that's plus 40 and minus 40 newtons. And then the excitation voltage 2.5 volt, that's okay. The bridge resistance of 350 ohms, that is okay. And then in this particular case here, we're going to use continuous samples. And I'm going to choose to read 100 samples each per loop iteration, reading at the rate of 1 kilosamples per second. So we have to choose continuous sample here because inside Signal Express, if you don't do that, it will cause the buffer to overflow. So let's just have a quick run and then see what can we see from this. So now we're reading something that's jumping between around sort of 60, basically 60 Newton. Just for the ease of understanding, I turn off auto scale and then I make it 100. And 0. So So you can see the signal sort of right now is sort of sitting around 60. The reason for that is because we haven't done offset nulling on our analog input device. But just to show that it is working as expected, right now I have a 4 kilogram dumbbell as my reference weight. I'm going to drop this on the low cell. As I release the weight on the low cell, you can see now the signal is close to sort of 100 newtons. So it moved up by another 40 newtons, which is about 4 kilograms. So you can see that it is working as expected. The other thing to note is that your maximum input range and minimum input range should not exceed the input range of your DAC device. For this particular one, 9237, that is 25 millivolt per volt, which works out to be about, say, about 500 Newton. So if I make it 500 Newton, and if I try to run it, it will still work. But if I make it 600 Newton, it will throw an error. As you can see that it automatically calculated for you, so the range should be plus and minus 500. So let's come back to 40. Yeah. And then the second thing is that the scale unit, I can also turn it into other sort of default scale. Say for example, if I make a kilogram force, it will automatically adapt whatever that's in the configure scale to the kilogram Newton. So you can see now the value has dropped from 60 newtons to roughly about 6 kg. So if I apply to it, so it will work. You can see so about 4 kg is added to the force. And then because of that, our input range, we also want to change that. So to 4 kg to minus 4 kg. Which brings us to the second part of this video, which is how are we going to calibrate our input device. So you do so by going to the second tab, device tab, and click bridge calibration. So in this DAC MX calibration, you have two things. There are two options you can calibrate. You can enable offset nulling, which will set the input setting to 0. You can also enable shunt calibration, which allow you to calibrate gain errors. For the time being, first of all, I'm just going to show you offset nulling. So once you select enable offset nulling, click next. It will automatically measure and then calculate the errors that's from the expected value. And then if you click calibrate, it will add the changes, apply the changes to your device. So now if we run our code again, you can see that the signal is now sit squarely at 0. And then which we can apply again, try our reference weight to it, and then it will give an expected result. So you do shunt, if you want to do shunt calibrations, you apply a known resistance in parallel to one of the branch, and then it will calculate the difference between the estimated value and the actual measured results. This will help you calculate the gain error of the device. So for the NI9237, it has a built-in 100 kilo ohm shunt resistors to it. You do have to manually wire the shunt resistors to the desired branch though. So in this particular example here, I have wired the terminal block to the input of the shunt resistors. The details about the wirings will be included in the link at the bottom of this video. So I can also enable the shunt calibration with the 100 kilo ohm resistors built in, and calibrate, which will give me a better gain error measurements. So the last part of this video, I'm going to show you how you could calibrate the whole system by using the going to the calibration tab here. So in the calibration tab, if you go into the tab, it will ask you for the calibrator's name. So I will key in my initials and then go next. It will ask you the configuration you want to use for calibration. So we will read 1000 samples at the rate of 1 kilohertz. That's fine. And then it will ask you to key in the reference value. So the reference value, the first value we want to do is say for the 0, we know that right now there is no weight applied to it. So for 0 weight, the unit is in kilogram force. What kind of values we should apply to the unit? And then let's go to the next row. Commit. So you can only calibrate for the reference that you have. So in this case, again, it's a 4 kilogram dumbbell that I have here. So I apply to that. And then I commit calibrated. Oh, I have to type in the 4. And I commit the value to it. So we're not going to add any more, so this 2 is enough. Yeah. So the calibrated value is then now committed to the calibrated scale. So this one, the calibrated scale will override your configured scale. But for the range, for example, my configured scale has a range of -4 to +4 kilogram, which I do not have a physical unit to calibrate it, calibrate the -4 tension. So it asks me if I want to use the pre-recorded unit, the reference unit, and I say yes. So which will generate a calibrated plot, which the top segment is what I calibrated with a physical value, and the bottom segment, it uses the default calibrated scale. And I click finish. So now I have a channel that is totally calibrated and able to measure signal up to 4 kilograms. So this concludes the end of this video.